When we want to prove a statement of the form negation of P, then proof by contradiction can be a good idea to try. And the way it works is you will just take P as a given and then try to somehow derive a contradiction from that. And if P being true leads to a contradiction, then we know that in fact P is not true. So negation of P is true. So in this problem, we're supposed to use the method of proof by contradiction to prove the following theorem. Suppose A intersect C is a subset of B, and A is an element of C. We want to prove then that A is not an element of A minus B. So let's try and sketch this and see if we can understand why this might be true. So we have A intersect C appearing, so maybe I can make an A and a C. And the intersection of the two in here is a subset of B, so B might be something like this. Okay. And then we're also assuming that A is in C, so it's somewhere in this set here. And we're supposed to conclude that A is not in A minus B, which are all the elements which are in A and not in B. And so A minus B would be something like this. I feel like I'm in kindergarten trying to color in between the lines. Okay, and so if A is in C, it's pretty clear from the picture that it could not be in this region over here, right? And what would proof by contradiction look like? I guess we would assume that it is in A minus B, and also that it's in C, and somehow get a contradiction out of that. Okay, so that's what the logic's going to do for us. We have our givens and our goal, and we will we're thinking of this goal as the negation of a statement P, and the statement P would be that A is in A minus B. And our new goal is a contradiction. So how can we combine these things? Well, first of all, we should probably just write out the definition of A being in the difference of these two sets, which means that A is in A and A is not in B. Okay. And then we have A intersect C appearing, and then we know that A is in both of those sets. So maybe we should write that, in fact, A is in the intersection of A and C. And then that, together with the fact that A intersect C is a subset of B, implies that A is in B. Okay. And technically, I should probably be writing out the definition of subset here in logical terms and using modus ponens, but you've seen those steps before, so let me just abbreviate it a little bit, save some time and space. And A and B together with A not in B certainly gives us a contradiction. Okay. So let's write this one down. Remember, the first thing we did was to take this goal and take its negation as a given. So we'll say, suppose for contradiction that A is in A minus B. Okay. And that's how we indicate to the reader that we're about to do a proof by contradiction, so that they don't wonder what we're talking about. And then after that, we just use the definition of set difference to arrive at these two statements. So we'll say then A is in A and A is not in B by the definition of set difference. And next, because A was in both C and A, we can summarize that by saying that it's in the intersection of A and C. So because A is in A and A is in C, it follows that A is in A intersect C, just by the definition of intersection. And then we combined that with the subset statement to conclude that A is in B. Right? So say because A is in A intersect C, and moreover A intersect C is a subset of B, it follows that A is also in B. Okay? And certainly the definition of subset is involved there, and as I mentioned earlier, there's sort of a hidden instance of modus ponens there if we had written out the definition logically. Alright, and then, well, the last thing to say is just that we have a contradiction, right? That gets us our goal. So I've just said that A is in B, and now I'll say this contradicts the fact that A is not in B, which occurred right up here in our proof. Okay. So we're done, but I like to put one more sentence here at the end, sort of closing off the proof by contradiction. Remember, we supposed that A was in A minus B. We got a contradiction, so we should say, therefore, A, in fact, is not in A minus B. Okay. And that was what we were trying to prove. And now we're done.